If valve overlap is maintained or even increased, oxides of nitrogen can be reduced by an exhaust gas recirculation or EGR valve connected between the exhaust port or manifold and the intake system. If engine conditions are likely to produce oxides of nitrogen, the EGR valve opens, letting some gases pass from the exhaust into the intake system. During combustion, these exhaust gases absorb heat from the burning air and fuel. This lowers peak combustion temperatures, which reduces the formation of the oxides of nitrogen. The EGR valve usually opens when the engine is at normal operating temperature and likely to be using a lean mixture. When the engine first starts and until it warms up, a temperature-sensitive valve prevents manifold pressure reaching the EGR valve and stops it from operating. Manifold pressure reaches the valve when the engine is warm and when the EGR port at the carburetor is influenced by the position of the throttle. This is generally at light throttle openings, when a lean mixture could cause increased oxides of nitrogen. It does not operate at idle or at wide open throttle. Oxides of nitrogen can also be reduced by retarding ignition timing. This lowers the maximum temperature reached during combustion. The maximum ignition advance setting is then said to be emission limited. However, it also lowers engine output and increases fuel consumption. Spark control systems use ignition timing to optimize engine output and fuel consumption with minimal emissions. They control vacuum levels to the vacuum advance unit on the distributor. In some designs, vacuum signals are delayed with vacuum valves in the signal line. In other designs, the vacuum signals are sustained. The signals can also be applied to dual diaphragm advance units on some distributors. The degree of control needed depends on many other factors, and each application should be considered individually.